Algebra 2, set 96, joint and combined variation, more on irrational roots. Okay, so we're going to be talking about direct and indirect variation and joint variation. So just a quick review, if you have a problem that says peaches vary directly as apples, we can write that as P equals Ka. K is the constant of change. And there's also another way to write that. We can write P1 is to P2 as A1 is to A2. That's the ratio form. If we're going to say peaches vary inversely as apples, then P is going to be equal to K over A, or P1 is to P2 as A2 is to A1. Notice that we switched the A2 and the A1. So in the first problem, A1's on the top and it matches, so they match here in direct variation, and then here they don't match for inverse variation. They switch. Whoops, you get what I'm saying. So now let's talk about what happens when you have varying jointly. Peaches vary jointly as apples and raisins. Jointly is kind of the same thing as saying directly, except that you have more than one thing. So peaches vary jointly as apples and raisins. It's just saying that you have two things that are varying directly. So apples and raisins multiplied by K is equal to P. And then the other way that you can write that in ratio form, P1 over P2 equals A1 over A2 times R1 over R2. So A1 R1 over A2 R2. Now, if you have peaches vary inversely as apples and raisins, then it's inversely as both of those. So peaches equals K over AR. So then P1 over P2, and then we switch both apples and raisins. A2 over A1, R2 over R1, or A2 R2 over A1 R1. So again, you should be able to notice the difference between these two. That is that A1 R1 are on the top, and here A1 R1 are on the bottom. Okay, now here's another example of a problem you might run across. Girls vary inversely as boys and directly as teachers. So if we're talking about girls varying inversely as boys, that means boys is going to go under K, so K over B, and then directly as teachers, so teachers is going to stay on the top. So girls vary inversely as boys and directly as teachers, and that K stays in the numerator. Now if we do the ratio of that, G1 is to G2, and then inversely as boys, so we take those boys and flip them, B2 over B1, but directly as teachers, so we leave teachers T1 over T2. Let's do an example. The number of girls varied inversely as the number of boys and directly as the number of teachers. When there were 50 girls, there were 20 teachers and 10 boys. How many boys were there when there were 10 girls and 100 teachers? Work the problem twice. First use variation and second use ratio form. So we'll start with variation. We know that we have a K for our constant, and it's saying that girls varied inversely as boys. So we'll start with girls and our constant, and since it's inversely as boys, we're going to put boys on bottom, and then directly as teachers. So directly means it's going to stay on top, so teachers is going to go on top. And then we can fill in some information. It says when there were 50 girls, there were 20 teachers and 10 boys. So we're just plugging in for girls, teachers, and boys, and then we can solve for K. So I'm going to cancel out those 10s, and then so 50 equals 2K, so K equals 25. So now I can take that information that K equals 25 and use that with our new information. It says how many boys were there when there were 10 girls and 100 teachers. So we're going to let G equal 10, and then K is 25, and T is 100. And then we want to know B. So multiply both sides by b, we end up with 10b equals 2,500. Divide by 10, we get b equals 250. So there were 250 boys when there were 10 girls and 100 teachers. Now that's our first way. Now we need to do the second way, and I'm just putting the problem there again so we have the information. And now we're doing ratio form. So again, we have girls, so we need to do G1 over G2. And then it says inversely as boys, so we're going to put B2 on top and over B1, and directly as teachers, so T1 over T2. And then we just fill in our information. When there were 50 girls, there were 20 teachers and 10 boys. So all of those are subscript 1. So girl 1 is 50, teacher 1 is 20, and boy 1 is 10. Now we come down to our other information. How many boys were there? So B is going to be our variable. When there were 10 girls and 100 teachers. So we're solving for B, or in what I've written is X. And we just need to solve from here. We can cross multiply. 10 times 20x is 200x. And then 50 times 10 times 100 is going to give us 50,000. We can cancel out 2 of those zeros. And so 2 goes into 500 250 times. So there's 250 boys. Let's do another example. Strawberries varied jointly as plums and tomatoes. If 500 strawberries went with 4 plums and 25 tomatoes, how many plums would go with 40 strawberries and 2 tomatoes? First, work the problem using variation. Work it again using the equal ratio form. So, strawberries varied jointly as plums and tomatoes. So it's just a straight across equation. Then we can plug in S is 500, P is 4, T is 25. So 500 equals 100K, K is equal to 5. Then we come to the next part. It says how many plums would go with 40 strawberries and 2 tomatoes. So we know K is 5, 40, 2, and we don't know what plums are. 5 times 2 is 10, so we have 40 is equal to 10p, so the number of plums is 4. Now that's our variation form. Now let's use the equal ratio form. So it says strawberries vary jointly as plums and tomatoes. So strawberries, and then it's going to be plums and tomatoes over plums and tomatoes, 1s over 2s, because everything is a direct variation here. And we just plug in 500 strawberries, 4 plums, 25 tomatoes, and then on the bottom we have 40 strawberries, 2 tomatoes, and we don't know how many plums. So from here, 4 times 25 is 100, 100 divided by 2 is 50. We can cancel on the left, cancel out a 10. 50 over 4 is equal to 50 over P2. So you can work it out, but 50 over 4 equals 50 over P2. We can see that it's obvious that P2 is equal to 4. So we got the same solution for each problem. Okay, now we're going to look really quickly at systems of equations. Yesterday we did a problem that looked like this. We ended up getting a quadratic equation and we ended up factoring it. In the real world, that never, ever, ever happens. You can never take a quadratic equation and factor it and have it come out to a nice, neat answer. So most of the time, factoring is useless in solving these kinds of problems. So what we're going to do is show what you do when it doesn't factor, and that is we're going to use the quadratic formula. So solve the system of equations. We get x is equal to 6 over y, and then take that and plug it in. 6 over y equals 2, 6 over y minus 2y equals 3. Multiply everything by y, so we get 6 minus 2y squared equals 3y. 2y squared plus 3y minus 6 equals 0. We just got everything all over to one side. And then we have a is 2, b is 3, and c is negative 6, because At this point normally is where we would factor, but factoring is going to be a big mess in this case, so we're just going to jump right into the quadratic formula. So if you remember, the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're dealing with y's, so this is going to be y equals. So opposite of b is negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 6 all over 2 times 2. And again, we're just using a, b, and c to plug in the quadratic formula. So this simplifies, we get negative 3 plus or minus the square root of 9 plus 48, 4 times 2 times negative 6, and 4 is negative, so it's positive 48 all over 4. We get negative 3 plus or minus the square root of 57 over 4. So this is just the first part of our problem though. We have figured out what y can be. Now we need to take it and plug it back in for x. So there's our y. Now we're going to take it and plug it back in. So we get x minus 2 times y equals 3. And since we have a positive and a negative, we're going to have to do it twice. We'll do it this time with the positive. When we multiply here, we get x, and then negative 2 times negative 3/4. The 2 is going to cancel with the 4, so we're left with negative times a negative is positive 3/2. And then the 2 is going to cancel with the 4 again when we multiply by the square root of 57, so we get minus square root of 57 over 2, and all of that equals 3. So now we just need to solve for x. So when we subtract 3/2 from 3, this is the same as 6/2 minus 3/2. 6/2 minus 3/2 is going to give us 3/2, and then we're going to add square root of 57 over 2. So now we're going to take the exact same thing. We're going to take this y again, but we're going to take the negative version of it and plug it in. So we get x minus 2 times negative 3 minus square root of 57 over 4 equals 3. And if you notice, everything's pretty much the same except for that negative sign. So instead of minus square root of 57 over 2, it's going to be plus square root of 57 over 2. Everything else is the same. Negative 2 times negative 3/4 is going to be 3/2. Negative 2 times square root of 57 over 4, it's negative square root of 57 over 4, so it's going to be positive, and that's equal to 3. Then we subtract 3/2 and subtract square root of 57 over 2, and we end up with 3/2 minus square root of 57 over 2. So we have 3/2 plus square root of 57 over 2 and negative 3/4 plus square root of 57 over 4. And then we also have 3/2 minus square root of 57 over 2 and negative 3/4 minus square root of 57 over 4. This is just taking our x and our y and our x and our y. I'm going to fix this so that it looks a little bit, it's just what I had written there kind of overlapped there. So hopefully that makes sense. We got our y's. The y's come from this place here, and then the x's come from here and here.